Hello, I'm Dr. AJAY Gambier, a Senior Research Fellow at the Grantham Institute at Imperial College London. I work on low carbon pathways, mapping out how different countries and the world as a whole can transition from a high carbon economy that we currently have to a very low carbon economy in the future. Decarbonising the electricity sector through increasing the share of renewables is a key part of doing that. In this video, I'm going to first give you a grounding in how electricity systems work. This will then set you up for further topics in this course, which will look specifically at the different challenges and implications for these systems when we integrate increasing shares of renewables like wind and solar panels into them. We'll learn about how we can cost effectively do this integration without compromising the safety, stability or reliability of electricity systems. Demand for electricity varies over time, and these changes happen across different timescales. At the sub-second level, from second to second, hour to hour, day to day, seasonally and from year to year. As you can probably imagine, national electricity demand will be very different on a cold, dark morning during the working week compared to a sunny, warm afternoon on a weekend. People need to use lighting, heating, air conditioning and appliances at different times, in a way which isn't completely predictable, even if it follows reasonably regular patterns when aggregating across many households and businesses. Electricity systems are designed to ensure that supply meets demand, economically and reliably. The minimum level of demand is often referred to as baseload, and historically in all countries, some power stations have run all of the time to meet the baseload. Meeting the rest of the demand and dealing with demand variations during the day and year can be done in a number of ways. Most countries use flexible generation plants, mainly fossil-fueled, which can increase and decrease their output as and when needed. Electricity can also be traded across interconnectors, and some countries are able to use the energy stored in hydroelectric dams to respond to changing demands. The order in which power stations are deployed, with those plants with the cheapest operating cost first and more expensive plants afterwards, is called the merit order, and is an important concept in electricity system operation, as it keeps the system operation costs to a minimum, which is explained in further detail in the additional information accompanying this video. As well as ensuring supply meets demand, electricity systems must also perform a number of other functions. A key part of ensuring demand is met is ensuring there are enough power generation plants to meet the very highest level of demand in the year, which is called the peak demand, as well as ensuring a healthy margin in case peak demand goes above the levels that are forecast for a particular year. This is called the capacity or reserve margin, or sometimes the planning reserve. All electricity systems consist of a set of key components: the power plants to supply electricity, other plants and mechanisms that provide the ancillary services, the transmission lines to transport the electricity, typically over long distances, and local distribution networks, which connect the transmission network to customers. Electricity systems are networks of interconnected transmission and distribution wires carrying alternating electrical current at specific frequencies and voltages. It's important that these frequencies and voltages are maintained throughout the system, otherwise there could be damage and loss of transmission. Some electricity generators specifically provide what we call ancillary services. These help to maintain frequency and voltage stability during normal operating conditions and help the system recover from disturbances to these operating conditions. In most countries, system operators are responsible for ensuring that electricity supply meets demand, though they do this to varying degrees, with full coordination of the system in some countries and less of a role in countries where much of the supply and demand for electricity are matched through power exchanges and/or through direct contracts between suppliers and users. who owns what components of the system varies from country to country. In more liberalised countries, different companies may own power stations, transmission lines and distribution networks. But in each system it is the government and regulators that set and enforce the rules of operation of the system. So that's Electricity Systems 101, and I hope that gives you an idea of what these systems are designed to do and how they generally perform these functions. Different countries have different mixes of generators and different operating arrangements. In the next topics, we'll look at the operating characteristics of different generation technologies, and then we'll consider specifically what happens when we add increasing penetrations of solar photovoltaic panels and wind turbines to these systems. These technologies have weather-dependent and therefore variable electricity generation outputs, and this makes them somewhat less predictable than conventional generators. Understanding what implications this has for electricity systems and how we can cost-effectively integrate renewables like wind and solar into these systems will form the basis for the rest of this course.